Pluto is a distant and mysterious dwarf planet, once considered part of our solar system's planetary family. However, recent startling announcements by leading astrophysicists Neil deGrasse Tyson and Michio Kaku have thrust Pluto back into the spotlight. They suggest that this icy world may be on a potential collision course with Neptune. But how could this happen, and what would be the consequences of such a massive event? Are we witnessing a rare astronomical phenomenon, or is there something more to this impending collision? Join us as we explore the possibilities of a Pluto-Neptune impact. Pluto, a former planet that was demoted to a dwarf planet partly due to its peculiar orbit, remains a subject of fascination and study in the astronomical community. According to recent predictions by leading scientists, Pluto's trajectory is dangerously close to Neptune's. Leading astrophysicists Neil deGrasse Tyson and Michio Kaku are both raising alarms about a potentially hazardous collision between these two planets that could pose a huge threat to Earth. How is such an event even possible? Pluto's journey around the Sun is unlike any other planet in our solar system. It takes a staggering 248 years to complete a single orbit, meaning that since its discovery in 1930, it hasn't even finished one full revolution. But the intrigue doesn't stop there. Pluto's path is marked by its highly elliptical shape, deviating significantly from the near-circular orbits of the major planets. What makes Pluto's orbit even more peculiar is its inclination, angled at 17 degrees to the ecliptic plane. The path Pluto traces is much steeper compared to the other planets, adding layers of complexity to its orbital pattern. One of the most intriguing aspects of Pluto's orbit is its intersection with Neptune's path. For about 20 years in each orbit, Pluto actually comes closer to the Sun than Neptune, defying what we might expect from their positions in the solar system. This leads to the natural question: why hasn't Pluto collided with Neptune? The answer lies in the gravitational influences of other planets. The study of Pluto's orbit began soon after its discovery. Initially, astronomers struggled to understand its unique trajectory. Unlike the other planets, whose orbits lie relatively close to the ecliptic plane, Pluto's path stood out with its steep inclination and elliptical shape. The mystery deepened with the realization that Pluto's orbit actually crosses Neptune's. The stability of Pluto's orbit amidst these complexities is proof of the intricacies of space mechanics. The three-body problem in space involves figuring out how three objects in space, like Pluto, Neptune, and the Sun, move and affect each other with their gravity. It's like trying to predict where they will go based on where they start and how they pull on each other. In Pluto's case, this problem shows how its path, Neptune's path, and the Sun's gravity all work together in a complex way. The terms libration and latitude libration, along with the VZK oscillation, are part of this puzzle. According to astrophysicists, what's keeping all planets in their orbits is a phenomenon called libration. In the context of Pluto and Neptune, this term means that whenever Pluto crosses Neptune's orbit, it's positioned at least 90 degrees away from Neptune. This spatial separation is crucial in preventing their paths from colliding. Latitude libration, on the other hand, refers to the vertical movement of a celestial body in its orbit. For Pluto, this means that when it comes closest to Neptune or any other giant planet, it's situated significantly above their orbital plane, providing an additional layer of protection from potential collisions. Another crucial component in this equation is the VZK oscillation, named after three scientists, von Zeipel, Lasker, and Callow, who studied how things move in space. It's about how three space objects like Pluto, Neptune, and the Sun pull on each other with their gravity. This pulling affects how they move. In Pluto's case, VZK helps us understand why its path around the Sun is so unusual. Even though Pluto's path seems all over the place, this oscillation helps keep it moving smoothly for a long time. The VZK oscillation shows that even if things in space seem wild and random, some patterns and rules keep everything in order. All of these components help keep Pluto's orbit stable, making sure it doesn't crash into Neptune or get thrown off course. This three-body problem helps in understanding how these paths change because of the way these space objects pull on each other. Studying this helps us learn about Pluto, our solar system, and distant worlds and their stars. Numerical simulations in the late 1980s revealed that despite these stable properties, Pluto's orbit is technically chaotic, with minor deviations in initial conditions leading to significant differences over millions of years. However, these unique properties of Pluto's orbit have been found to maintain stability over incredibly long time scales, effectively keeping the chaos at bay. Recent computer tests have helped us understand how the big planets like Neptune, Jupiter, and Saturn affect Pluto's path around the Sun. Neptune has a special connection with Pluto, where for every 2 rounds Pluto makes around the Sun, Neptune makes 3. This connection helps keep Pluto's path steady. But Neptune isn't the only one helping. Jupiter's gravity also plays a big part in keeping Pluto's orbit safe and stable, and Saturn helps a bit too. These tests show that Jupiter's gravity alone is strong enough to ensure Pluto stays on a stable path for really long times, even billions of years. It's like Neptune, Jupiter, and Saturn are all working together to make sure Pluto keeps moving safely in space without running into trouble. These phenomena are essential for maintaining the order and predictability of space bodies' movements in the universe. Without these mechanisms, the solar system as we know it would be a place of much greater chaos and unpredictability. Bodies like Pluto could potentially collide with others or be ejected from their stable paths, leading to a domino effect on other celestial bodies. Understanding Pluto's orbit is crucial, especially in light of discussions about the possibility of it crashing into Neptune in the future. Pluto's trajectory offers a unique insight into the dynamic nature of our solar system, revealing the intricate dance of celestial bodies governed by the laws of gravity and motion. By studying Pluto, scientists gain a clearer picture of how even the most seemingly unstable orbits can achieve a state of equilibrium through the complex interplay of gravitational forces and orbital mechanics. This case underscores the importance of continuous observation and study of these phenomena, not only to better understand Pluto itself but also to deepen our understanding of the universe and our place within it. Pluto's orbit is particularly fascinating because it defies the more predictable and stable paths followed by other planets. While the major planets of our solar system, such as Earth, Jupiter, and Saturn, have relatively circular orbits, Pluto's path around the Sun is highly elliptical and tilted. This eccentric orbit causes Pluto to cross Neptune's path, a phenomenon that naturally raises concerns about a potential collision. However, despite this apparent danger, Pluto and Neptune have coexisted in this way for billions of years without incident, thanks to the intricate gravitational relationships that govern their movements. The importance of understanding Pluto's orbit becomes evident when considering the potential consequences of a collision with Neptune. Such an event would not only alter the structure of the outer solar system but could also have ripple effects throughout the entire solar system, potentially impacting the orbits of other planets, including Earth. The gravitational forces involved in such a collision could eject debris and alter the trajectories of other celestial bodies, leading to a cascade of changes that could take millions of years to stabilize. This hypothetical scenario highlights the delicate balance that exists within our solar system and the importance of studying the factors that maintain this balance. One of the key concepts in understanding Pluto's orbit is the idea of orbital resonance. Pluto and Neptune are in a 2:3 resonance, meaning that for every 2 orbits Pluto makes around the Sun, Neptune completes 3. This resonance ensures that the 2 bodies never come close enough to collide despite their intersecting orbits. The gravitational forces exerted by Neptune on Pluto and vice versa are precisely balanced in such a way that they keep each other in check, preventing any catastrophic encounters. This orbital dance is a prime example of how celestial mechanics can create stability in what might otherwise seem like an unstable system. The study of Pluto's orbit also contributes to our broader understanding of the solar system's history and evolution. By examining the specific characteristics of Pluto's orbit, scientists can infer the past interactions between the planets and other objects in the Kuiper Belt, the region of the solar system beyond Neptune where Pluto resides. These interactions have likely shaped the current configuration of the solar system, and understanding them can provide clues about the processes that have governed the solar system since its formation over 4.5 billion years ago. Moreover, Pluto's orbit serves as a case study for understanding the behavior of other distant celestial bodies, both within our solar system and in exoplanetary systems around other stars. The principles of orbital mechanics that apply to Pluto can be used to study other objects in the Kuiper Belt, such as the dwarf planets Haumea and Makemake, as well as other trans-Neptunian objects. By understanding how these distant objects interact with the major planets, scientists can develop models that predict the behavior of similar systems elsewhere in the galaxy. This knowledge is essential for the search for habitable exoplanets, as it helps to identify stable planetary systems where life might exist. Continuous observation and study of Pluto's orbit are essential for several reasons. First, it allows scientists to refine their models of the solar system's dynamics, improving our ability to predict the future movements of planets and other celestial bodies. This predictive power is crucial for planning space missions and for assessing potential threats from asteroids or comets that might come close to Earth. Second, ongoing study of Pluto's orbit contributes to our understanding of the processes that shape the solar system over time, including the effects of gravitational interactions, collisions, and the migration of planets. These processes have played a crucial role in the formation and evolution of the solar system, and by studying them in the context of Pluto, scientists can gain insights into the broader mechanisms that govern planetary systems. Finally, the study of Pluto's orbit has implications for our understanding of the universe as a whole. The principles of orbital mechanics are universal, meaning that the same forces that govern the movements of planets in our solar system also apply to other planetary systems throughout the galaxy. By studying Pluto, scientists are contributing to a body of knowledge that can be used to explore and understand the vast and complex universe in which we live. Pluto's orbit, though once considered an anomaly, has proven to be a source of invaluable knowledge about the intricate workings of the cosmos, and its study will continue to be a vital part of astronomical research for years to come.